Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by Mandrill. Mandrill is a scalable, reliable, and secure email infrastructure service trusted by more than 300,000 customers. Sign up at mandrill.com, promo code TWIT, and you'll receive 50,000 free email sends per month for your first 6 months of service. Welcome to Coding 101. It's the Twitch show where we let you into the wonderful mysteries of the Code Monkey. I'm Father Robert Ballester, the digital Jesuit, and this is one of our super special sports ball wild card episodes. The idea, of course, is that as we change the format, as we start to move more towards looking at the tips and the tricks and the methods and the secrets of coding gurus, that we actually sit down and speak with them before they guide us through a module or two. The man I have as my guest for this episode is someone that I met 3 years ago at DEF CON. He's known as Smitty. You'll know him if you ever go to DEF CON because he's probably the only one in the hardware hacking village wearing a kilt. It's Mark Smitty Smith.
Very much not.
No.
Kilts are very common at DEF CON. I am not the only one there by any stretch.
Well, yes, but in the hardware hacking village, you're the only one that wears a Utilikilt, I believe.
No, I think there are about 3 or 4 others that are there commonly. I'm probably the only one there with a Utilikilt and a floppy leather top hat thing.
Yes, which I really... By the way, at one point I need to talk to you about that. It's totally unrelated to Coding 101 because
fair enough.
The steampunk accessories that you have are top-notch. I want to know how to make those things. But let's talk a little bit about you. You are a different kind of coder. We've had guests on this show who have done many of the popular languages, so C#, a little bit of Python, a little bit of Perl. You don't do those languages. You specialize in embedded devices. Can you tell me a little bit about how you got to that?
Well, to be clear, I do those other things as well, but I also do the embedded stuff. How I got started into that, I've always been into electronics. Hooking up batteries to light bulbs when I was in kindergarten and 2nd grade and doing those kinds of projects and having a lot of fun with that. When I got into college, way back in the early 90s, microcontrollers were just becoming a thing. Back then it was the 8051 and the 68HC11. The 8051 is a early Intel microcontroller, and the 68HC11 was an early Motorola microcontroller. And a microcontroller is basically a CPU with a bunch of the memory controller and digital I/O built into it. So it was a single chip that you could use to do pretty much everything. You didn't need a lot of peripherals. You could control things directly from the output of the CPU instead of having to go through some other chips that would take like a memory map from the CPU and turn it into actionable things, like pins that you could use to turn on and off lights or open and close relays or whatever it is that you're trying to control with your microcontroller. And I liked the microcontroller because it was something that you could use to actually make changes to the real world instead of just flipping bits and maybe drawing some polygons on the screen or whatever. It wasn't just a virtual thing. You could actually turn it into a physical thing. And that really appealed to me. Spent, the vast majority of my childhood tinkering with Legos. And I would make a lot of robots with Legos, robotic arms with the Technic kits and everything, and with the gears and all that and the motors. And I made a switch box with a bunch of switches on it that would control the motors. And I could use that to control the robotic arms to pick things up and move them around and do all that kind of stuff. And so being able to merge my love of computers with the love of physical things with microcontrollers just kind of seemed like a natural progression. And that's how I got started. And then the BASIC stamp came around. I went there next. And then the Arduino. And the Arduino kind of broke the dam loose. And I've been going hog wild with Atmel and Arduino ever since.
Smitty, it's fascinating that you say that because I think I was in the same boat as you. I started off with programming computers. In fact, I had a Timex Sinclair, and then I upgraded to an Atari 5200. That thing was
Nice.
amazing. And then a TI 99.4A. And I started with tinkering. I liked hooking up light bulbs. I would take things apart to figure how they work and then reconnect them in different configurations.
Oh, you actually rebuilt them.
Oh, yeah, that was
So
always
your
fun.
parents were lucky.
You just took them apart.
I just took them apart. Yeah, my parents have plenty of good stories about, put it back together at least.
We actually have someone here at the Twit Brick House who may be your soulmate. But you know, I love doing that. But then I went more the software engineering side. I kind of put away the tinkering, and I decided that the future was just going to be in code. It was going to be in code that did things on servers and in networks, not so much in the real world. And if it did it in the real world, it would be through someone else's module. I like the fact that you decided to stay with the physical world. It's a different kind of mindset. Now, take me to that. Tell me how you got to the decision to stay with embedded controllers, microcontrollers, rather than going pure computer engineering. I know that you like to tinker, but did you ever have to make a decision, like getting into college or getting into your training, where you decided this is the route I want to go as I move forward?
Not really. It was never a conscious decision. I've always been more into the hardware than into the software of things. I mean, I can write code, but I'm not a software developer. Those are two different skill sets. I started out in college as an electronic engineer major, as an EE major. And then I eventually switched to computer engineering, which is kind of a cross between EE and computer science, which was all programming. EE was all hardware, computer science was all programming, and I kind of did the one that was the merger of those two. It was never really a conscious decision of, gee, I don't want to go all software, I want to keep some hardware in there. It's just the way I went. My day job has primarily been as a network engineer and a system administrator, not as a programmer. So that's a lot of hardware, you know, making cables and that kind of stuff, not component level soldering level of hardware, but it's, you know, you're not writing a lot of deep applications, right? You might write some scripts to automate some things, but that's kind of it.
Let me stop you just, I want to backtrack a little bit, because you said something absolutely fantastic. I think that our audience is going to want to hear more about, and that is that computer software, computer engineering, computer science, that kind of programming is different than the embedded programming. But to the outside observer, they're going to say, wait a minute, it's all just code. Code is code, right? Why do I have to make a choice between one? Shouldn't a computer scientist be able to pick up an embedded controller and then just program? What makes it different, and what makes the mindset different?
So the point that I was trying to make is that software development is a superset of writing code. Writing code is, you know how to write a for loop. What does a for loop do? How do you write a while loop? You know, how do you kind of assemble these things into a program to get it to do what you want it to do? Software development is more about the life cycle of your code. How do you, you know, take requirements, and how do you do the, you know, the Scrum or whatever it is that you're doing for project management? How do you plan out how the larger project is going to fit together and work? And then, you know, you write the code, you test the code, you deploy the code, you find the bugs, you fix the bugs, you test the fixes, you deploy that, lather, rinse, repeat. That whole software development lifecycle is much more of what I consider to be software development, as opposed to just banging out code. For microcontrollers, you're very limited on the amount of code space that you have. You've only got a few kilobytes. Remember, kids, there are actually these things called kilobytes, and sometimes they are limits and not just multiples that you use to calculate how many terabytes you have, right? To make the number smaller. The microcontrollers that I work on, the big ones, have 32 kilobytes of flash. That's the largest program I can write. And some of the chips that I work on only have 2 or 8K of flash. And I'm working in RAM. I think the ATtinies have like 256 bytes of RAM. That's quarter of a kilobyte of RAM. That's very small systems. So when you're working on a system of that size, you can pretty easily keep it all in your head. You can remember how it all fits together. You don't have to compartmentalize things nearly as much. And so a few thousand lines, a few hundred to a few thousand lines of code to bang something out really quickly because it is such a special purpose device. It doesn't have to do a lot of things. You can be a code monkey and just write code and make that work. Whereas when you're doing a software development project like a website or a back-end server, you're talking about tens of thousands, hundreds of thousands, even millions of lines of code. You're not going to be able to keep all of that in your head. And it involves a lot more process and control and just everything wrapped around it. That's the part that I'm not very good at, is the point that I'm trying to make. And I've never really had formal training in it. I've done it for my day job for about a year. Didn't work out very well. I wasn't very good at it. And I went back to networks and systems because that's really where I'm the happiest and where I'm the most effective. But microcontrollers, because you have such a limited space, you can get away with doing just, banging away at code. And of course, I'm going to get all kinds of hate mail from embedded programmers saying, no, there's software development lifecycle is very important when you're doing embedded programming too. And that's very true. However, as a hobbyist, you can get away without all of that. And that's really where I've spent all of my time doing embedded programming, is as a hobbyist.
Smitty, I want to drag you into that war right now because I know people on both sides. I know people who have been doing nothing but embedded programming. In fact, I know a couple of people who pretty much all they do is they program SCADA devices. And then I know others who they make their living in professional development working for companies like Oracle and Microsoft. And anytime we get together, there's always there's a running joke of who is the more elegant programmer. Oh yeah. And the software guys they'll show you, oh well, my flow is so elegant and my logic tree is impeccable. And then the embedded guys will say, I have to do all of that, but I have to do it in 1,000th of the space that you get.
Yeah.
I don't want to say either is better, but
they're different.
Which one's better?
They both have their advantages and disadvantages, right? A lot of the old school programmers who had to deal with kilobytes of RAM will make fun of the new school for being so inefficient. I mean, the fact that our operating systems, our freaking kernels require, 10 times, 100 times more RAM than my first computer had total, right? That kind of thing and that's before you even load any applications onto it, right? To an old school programmer, that's just atrocious. It's like, oh, what an amazing waste. Why are you guys so inefficient? We could go in there and write this stuff so much better. But honestly, Dr. Moore predicted the solution to that problem decades ago, right? It's a hell of a lot cheaper to throw more RAM at a computer than it is to spend the time to tweak and optimize and really squeeze every single last, assembly instruction out of your algorithm and make things super efficient. Which one's better? It kind of depends on what you're trying to do, Yeah. So I'm going to decline to answer. I'm sorry, Padre. You're not going to get turn me into a sensationalist.
I wouldn't answer either. It's a bad way to be. But that point is exactly what my software engineering friends
love to debate.
And then of course the embedded guys will always say exactly that, which is you can be lazy because you have so much processing power, because you have so much storage, because you have so much memory. You don't get bit if you're a lazy programmer. As an embedded programmer, you can't be lazy. It just won't fit. And if it doesn't fit, that means you have to go back and you have to optimize. There's a certain logic to that.
The one thing I will point out is that if you get into an environment where you breed laziness in your coding, then you might start ignoring things like complexity levels. The big O notation. I don't ask me to define the details, but things like big O of constant or big O of n, big O of n squared, n factorial, those kinds of things. It's given a problem of size n, how many times do you have to iterate over n to be able to get the answer? And if you get too lazy, you might start ignoring those kinds of problems. And those kinds of problems still matter because they grow very quickly. And I have seen a lot of programmers get lazy to the point of writing not just inefficient code as in, oh, you could have combined these two lines into one line and it would execute faster. But instead of, maybe you've got to do 3 different things on this particular text file. Instead of looping over the text file once and doing each of the 3 things on every line, you instead, loop over it once, do one thing, then loop over it again, but for every line you loop over it for the one time you did, and you end up writing programs that just take way too long. And as your data input gets bigger, the complexity starts rising so much faster. And if you're not thinking about optimization, if you've got the mindset of I can be lazy, then those kinds of things tend to bite you.
Right.
So optimization is still important. I think it was W8SS Joe in the chat room just mentioned optimization is still key, and I think he's right. And we need to pay attention. He or she, excuse me. Oh, Joe, that's probably a he. I think he's right in that we do still need to pay attention to the inefficiencies of our code. We can make conscious decisions and say, yeah, I could spend a lot of time to optimize this and maybe squeak 10% out of it, but that's going to cost me X number of dollars in time versus Y number of dollars in savings of optimization. Compare those two numbers and make the decision.
I want to take a little side trip. It's going to be a small tangent, but I think it'll be worth it because I'm seeing this discussion going on in the chat room, and I actually hear this a lot, much to the ire of my embedded programming friends, and that is when people say, "Oh, well, with Arduino, now people can actually program a microprocessor," and they bristle a little bit because they were doing this way back, with Motorola embedded processors back when I was playing with my PCs. What's your take on this? Because of course, the Arduino really made it popular with the maker scene. It made it possible to easily, an artist, right? You could be an artist, someone with no knowledge of embedded programming whatsoever, and you could pick up an Arduino, follow a couple instructions, read some forums, and figure out how to make something work in the real world.
Yep.
What's your take on that? I mean, it's got to be a good thing, but at the same time, I've heard you at DEF CON grumble a little bit that, well, Arduino's okay, but you can't forget all this other stuff.
I don't think it was me that was grumbling about that. I think you might have, you're probably talking about the panel I was on 2 years ago?
Right.
Okay, so that panel, actually, I think I was the one who defended Arduino because I was the only non-professional embedded programmer up there. I was the only hobbyist. So here's the thing with Arduino. Arduino took a real honest-to-goodness microcontroller, an Atmega 328. I think they started out with the 16.8, the 168. But they took a real honest-to-goodness microcontroller. It's not a toy, right? It's a real microcontroller. And they took a real C compiler. It's not a toy. This is backed by GCC, right? The most popular C compiler on the planet. And they wrapped it with a pretty interface and made it very easy to use. And they removed all of the complexity of the build chain and all of the optimization tools and the assembler and the linker and all of that crap. And they just made a simple, easy to use IDE. And they didn't say you were programming. They said you were making a sketch, right? That appeals to an artist. That's not programming. And they basically made it very non-aggressive. They made it very non-computery. And I think a lot of the computer people got turned off by that. But let me give you a hint. All you artists out there who are doing things with Arduinos, you're writing C code. You might even be writing C++ code. You might be doing object-oriented programming and you don't even know it. That's awesome. All right. So we have made it so that it is so easy to do that people who wouldn't otherwise have gotten into the hobby are getting into the hobby because we didn't say it's like, oh, well, you've got to go, through all of these arcane steps and you have to install this package and this other package. And then you've got to take the output of this program and feed it into the output of it. We removed all of that. And it's just, here's how you write these commands in this interpreter or this IDE, the development environment, and you click this button and it will upload it to the Arduino. Done. And that's something that artists can get behind. So they kind of took the Apple approach, right? Apple originally, the original Macintosh wasn't targeted toward computer users. It was targeted toward artists, right? They're doing the same thing. They removed all the complexities. They hid it all underneath a good UI and turned it into something that anyone can use. I think there is nothing except good to come out of Arduino. Everything that Arduino has done has been good for the hobby. Because if you have an Arduino, you can still pull out your old school development environment and do all of your same libraries, all of the same compiler and everything else. It takes the same hex file output. and upload it to an Arduino hardware, and you get the nice hardware prototyping platform with all the shields and all of that, this kind of the standardization of somebody makes a module that you want to plug into your microcontroller to get it to do something, whatever that shield does. So you get to benefit from all of that for prototyping and still use your old tool chain. Or this is actually what I do. I use the Arduino IDE, and then I make my own embedded Atmel-based projects. And I think that's what you eventually want to talk to me about, is the Darknet project, or what I did there with the Darknet ID badge. That is all written with the Arduino IDE. I just told it to output, or to build, and I went into the template directory, grabbed the output file, and wrote my own AVRDude lines to program it out to the chips. The badge itself is Arduino compatible. You can program it with the Arduino software if you've got the right FTDI cable, which is a very standard, very common serial cable, serial on one side to USB on the other. I think it's fantastic. It's not as powerful as a lot of the commercial tools, and so a lot of hardcore embedded developers will say, well, Arduino doesn't do this feature or that feature or whatever. If you don't need those features, who cares? It really doesn't matter. And so if it gets more people into it and doing it, awesome.
Right.
I see nothing wrong with that.
Smitty, I'm on the same page as you. I think anything that gets people tinkering, I'm all for it. I think it's great. I think it's fantastic. And if people don't know that they're programming, I think that's even better, because then when they realize that what they've been doing is actually writing code for a microprocessor, it is a little sense of accomplishment. I want to take the other side, though. The dark side that I've heard from some of my embedded friends is Arduino is supposed to be a fast prototype. We know that. That's the whole idea of the shields. You get the hardware that you want, you code it, and then you've got your prototype. They would argue that many people never get past that. They never get past the prototype stage. They throw together a bunch of shields and they say, okay, I'm done, and now it's a product and I'm going to sell it.
Oh, well, okay. If you're saying it's a product and you're going to sell it, that's a different thing, right? If you're just doing a one-off project that you need, like, for example, in the other room, I've got a 55-gallon aquarium, 55-gallon fish tank, and I made a lighting controller. And it turns on and off LED lights and the CO2 injection and various other things. That is an Arduino with a shield, and I think another shield on top of that, connected to a bunch of different things. And I never went past that stage because I'm making precisely one of these things. I don't need to productize it and turn it into a dedicated board and send it out to be fabbed and assembled and test it and realize I screwed up and have to go have the boards refabbed and blah, 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 right? But if you are selling a product that is an Arduino with a shield stacked on top of it, unless you are selling it as like a Lego kit that you're allowing people to be able to disassemble and reassemble and all of that fun stuff, I think you're doing it wrong.
Yeah. When we come back, would you mind talking a little bit about process? Because I do want to pick your brain about when you see a project, when you see something in the real world, how do you pick your parts? How do you pick your components? How do you figure out what your logic tree is going to be? And then how do you actually get to programming it? And then I also want to talk about the Darknet, of course, because we both experienced the Darknet at DEF CON. Does that sound about right?
Sure.
Okay. But before that, let me just take some time to thank the sponsor of this episode of Coding 101. It's not Sports Ball. It's Mandrill. It's Mandrill. Now, these days, the vast majority of our attention is given over to the latest in social networking, to the greatest in messaging, and to the trendiest in collaboration apps. But for serious businesses and enterprises, there is still, after all these years of its first inception, nothing more pervasive, more useful, and more important than email. That's why I'm glad that this episode of Coding 101 is sponsored by Mandrill, a scalable, reliable, and secure email infrastructure service trusted by more than 300,000 customers. Oh, what is Mandrill, you might be asking yourself? Well, it's the easiest way to manage, integrate, deliver, track, and analyze email. It supports detailed delivery reports, advanced analytics, and a friendly interface that makes it easy for your entire team, from developers to marketers, to monitor and evaluate email performance across your entire business. Now, you can use Mandrill to send automated one-to-one emails like password resets and welcome messages, as well as marketing emails or customized newsletters. Mandrill started as an idea in 2010 and now they're the largest email-as-a-service platform on the market. Because they've geolocated their servers to maximize response times, Mandrill can deliver your email in milliseconds, and they've given you all the webhooks and the analytics that you need to check delivery rates. And the documentation to make integration is, well, just a breeze. Speaking of integration, Mandrill is easy to set up and integrate with your existing apps, so you don't have to switch everything over. It comes with a beautiful interface, flexible template options, customized tagging, and advanced tracking and reports. And they are the only email infrastructure service with a mobile app that lets you check and monitor delivery and troubleshooting from wherever you are. Mandrill is powerful, scalable, and affordable, but you know what? You don't have to take our word for it. Right now, Mandrill is offering a special deal to the members of the TWiT audience. Sign up at mandrill.com, promo code TWiT, and you'll receive 50,000 free email sends per month for your first 6 months of service. That's mandrill.com, promo code TWiT. mandrill.com, promo code TWiT. And we thank Mandrill for their support of Coding 101. Smitty, let's get back into it. So take me through the chain of logic that you would use as an embedded programmer, because we always do this. Every time we've gone through a language, we've taken our listeners and our viewers through what the logic chain might look like for breaking down a problem into your computer language. Let's take your aquarium. Let's say you wanted to do something with an aquarium. How would you decide what parts you're going to need, what microprocessor you're going to use, and how you're going to code it?
Actually, I'm going to request that we not use the aquarium for reasons.
Oh, okay. Yes.
Instead, I don't know if I made too much noise during the ad, but I ended up getting out all of my darknet boards from the very first prototype that I made up to the second prototype. This is actually the first one that we gave out at DEF CON, to the second year that we did. I've got to figure out which way to go with this. And then all the way up to the one that we did last year. And so I've got this kind of this history progression of this board, and they all basically do the same thing with a few additional components and whatnot. So let's use that one. But before we do, I wanted to make one comment. Loquacious in the chat room, I hope I'm pronouncing that correctly, mentioned that they really enjoyed Jerry Ellsworth and what she has done. And I have to totally agree. Jerry Ellsworth is an absolute inspiration. If you guys don't know who Jerry Ellsworth is, for embedded, for just anything makery, she is amazing. She is incredibly well-spoken. She's brilliant, totally self-educated. And she's just an absolute inspiration. She is fantastic. So if you ever get a chance to go see her talk or see any of her projects, or I don't know if she's doing a podcast or anything like that, but I think she appears on Twitter every once in a while. When you ever have a chance to go see her, please do. She's amazing. Okay, so you were asking what is the process I go through. Loquacious is a she, by the way. Thank you, Eric. What's the process that I go through? So for this particular instance, sorry, chiropractor's calling me to remind me of my appointment on Monday. Totally appropriate,
Thank you, Brian.
Thank you. Thank you, Brian. So this is let me see if I can get a little closer to the camera if it'll focus on it. Hey, there we go. You'll note that it's got come on, Smitty. A clear purple LED, a red LED here, a little 8-pin socket there, and then other side, opaque black LED, and a battery clip. What this is it's a small, tiny microcontroller. It's an ATtiny 85, which is an Atmel chip. And it has a couple of inputs and outputs that are literally just driving LEDs. The red LED is exactly what it looks like. It's a red LED, and it blinks Morse code, and this is how you get information out of the system, is that you have to decode the Morse code on this thing. The clear purple LED is actually an infrared transmitter, and then the opaque black LED is an infrared receiver. And if you have two of these things, and you kind of pair them back to back like this, they will talk to each other over the infrared and perform a crypto exchange, and will do stuff that I'll get into the details of talking about later. But what I wanted was a simple circuit that I could sell for inexpensive, for relatively cheap, that would give people an opportunity on how to learn how to solder, excuse me. I wanted something that I could sell for $5 or $10 at DEF CON and give people an opportunity to figure out how to solder. And then when they were done, I wanted it to be something that was functional, something that actually had a purpose. It wasn't just here's a blank microcontroller that you can do anything you want on. Well, what does it do? Well, you have to decide that. I didn't want that. I didn't want to have to put the onus on the person who's just trying to get into this to figure out figure out a project is the first thing. I wanted their first experience with soldering to result in something that was immediately functional. And I didn't want it to just be a Larson scanner or something that just blinked lights. I wanted it to actually perform a function. So in this case, I wanted a device that would be able to communicate with the other devices. So it needed an input and an output. All right, and we're using the IR for that. And I needed it to be able to communicate with the user. And so we have the red LED for that. So that's only 3 inputs and outputs, and that's not a whole lot. And the code that I was going to write was going to be pretty small. So I decided to use a tiny little chip. It's an 8-pin microcontroller called the ATtiny85. And it can run on a coin cell, a little 3-volt coin cell. So the whole thing was very small and very cheap. That was the selection criteria for this particular project. What I ran... Well, do you want me to get into the project right now?
Yes, please.
The whole darknet. Okay.
Do the darknet, because it's actually fascinating. It's not just programming. It's not just hardware tinkering. You actually had a vision into which all this hardware fit. And I just find that absolutely mind-boggling.
So let's give credit where credit is due. The vision belongs to Daniel Suarez. Any of you who have read the books Demon and Freedom TM by Daniel Suarez will get this right away. If you haven't read those books, get thee to your favorite bookstore and start buying them now. I personally am an audiobook person. I was kind of hoping that there would be an Audible ad on today so that I could talk about these, but another time. I'm an audiobook person. Jeff Gerner is the guy who reads them. I actually was sitting in one of the chairs right next to where you are right now, Padre, when Daniel Suarez and Jeff Gerner were in the studio for Triangulation. That was a very fun, fun day. Yeah. I got to go to lunch with them afterwards. That was cool. Anyway, in the book Demon, there is a demon, a computer demon, Daemon, that I'm not going to spoil it for you. Takes over the world. Summary. Yeah. Kind of that's general hand waving. That's not a spoiler. It's kind of like an MMO, a massively multiplayer online game, where there is this computer demon that's running on the internet somewhere and is communicating with its agents in the real life and having them do things for it on its behalf. But before it can have them do those things, it has to teach them how to do those things, right? And so I liked this idea of running a darknet at DEF CON where we could teach people how to do DEF CON-y type skills and then send them on missions to go to build things and accomplish tasks. And so kind of the root goals for the darknet are to teach people skills that they would not have otherwise learned, to get them to do things that they would not have otherwise done, and to meet people that they would not have otherwise met. Those are the 3 kind of main goals of the darknet. And the first year I did that was the thing we were going to teach was how to solder, because I'm a hardware guy. It's what I do, and that's when we made these kits. And then the meet people idea was that if you built one of these, and actually this was the board that we ended up using for the first year. If you built one of these, and it's got a little hole up here that you could hang from a lanyard, and if you saw somebody walking through the hallways that had one of these boards, you would say, "Hey, you, come over here, you're another darknet agent, come over here." And you meet them up, and you kind of piggyback the 2 boards back together with the infrared, and it performs a crypto exchange. Each one of these chips was programmed with a unique GUID and a unique private key. And I actually managed to program some very small crypto in here using the tiny encryption algorithm, TEA. And it performs an exchange across the IR that generates a code that is unique to the pairing of those 2 devices. And if you take that code and send it to the demon, then the demon can verify that you met the other player. and will grant you points for having done that, right? So you buy the kit, you assemble it, and it spits out a code that is your GUID. You send that to the demon, and the demon says, hey, I recognize that GUID. That belongs to one of the kits that we sold. This proves to me that you have successfully assembled the kit, and it gives you points for having learned how to solder, right? And then you go pair it up with somebody else, and you get some more points for that. Also note that there are some pins up here. It's kind of a 2x3 square, and then there's one pin kind of hanging off to the side over there. I will let you guys figure out what those are all for, but there are some Easter eggs in there that'll grant you some extra points. This one is 3 years old now, so I don't think the points for this one will still be granted. But anyway, and so that was the whole point of the demon. In the first year, I literally just did these, and that was it. Because I was trying to remain anonymous, because in the books, the guy who wrote the demon dies in the very first chapter. Again, not a spoiler.
Not a spoiler.
Like literally the first page is his obituary, right? So I'm not spoiling anything, but he dies, and he's not there to watch the execution of his masterpiece. So I kind of wanted to run all of this at DEF CON anonymously. That was my original goal, was to run it anonymously and just have it all be there and have it be a complete mystery as to who was doing this and where it came from, and just make it look like this random demon that was doing this thing at the event. I tried that the first year. This is all I got out of it, and it kind of worked, and it was kind of fun, but it didn't really scale well. And I'm only one guy, and I've got a family, and I can't really do all of that stuff by myself. So the second year, I kind of came out of the closet, as it were, and approached some friends and had them help me out. And this was the second board that we made. It is functionally very similar to the first board. You'll notice the 3 LEDs down here at the bottom. I've got the same microcontroller over here, and I've got the same programmer header there. But then all of the stuff on the bottom half is through-hole components. And so this was the learn how to solder through-hole. And then we sold a second kit that was learn how to solder surface mount for the top half. And instead of having to get everything by reading the Morse code out of the LED on the bottom, you could get serial data out of the USB connector at the top. And it was just an FTDI chip. They were real. This was not going to get bricked. And you could get serial data out of the top instead of having to decode the Morse code out of the LED. So that was the second year. And then the second year, I also had a friend of mine who works for a major game studio help me and rewrite the Demon backend. So we actually have a real honest-to-goodness quest engine where you can program in whatever kind of quest you want and interact with the players. And then just this past year, we upgraded it again. We did away with all of the surface mount stuff because that ended up being a very bad idea for the Hardware Hacking Village. We put way too much load on them. So we made the entire kit through-hole. We upgraded to a bigger microcontroller. So this one is the Atmega 32.8. I hate calling it the 328 because it's 32K and then 8K of RAM. I think 32K of flash and 8K of RAM. But we still have the IR transmitter and receiver down here and the USB port at the top that is useful for connecting and getting serial data. Instead of emulating a serial port, it now emulates a USB keyboard, so you don't have to worry about any drivers or anything like that. But otherwise, functionally, it's very similar. It performs the same function. And if you take this one and connect it up to this one from last year, they will still work. It's the same protocol. So we've retained backward compatibility on all of these.
Yeah. Smitty, when you were putting together this project, can you give me a little bit of insight into how you spec'd out the hardware? Because, of course, you started to think about, well, how many agents is this person going to meet, and how much capability do I want to build into this badge? Do you run into feature creep like software developers do, where you get to a point where you realize, no, I got to cut it off. This is it for this kit. Maybe in a future upgrade, revision of this hardware, I'll change it. But this is where we've got to be now. Yeah,
I did. The early ones, I had an ATtiny 85, and so there wasn't a whole lot of feature that I could fit in there. I mean, just the basic functionality already took up, I think, 6.5 of the 8K of flash I had available to me. So I didn't bother trying to add anything else. I had all kinds of great ideas of like, oh, well, we could add a TVB gun, or we could add a, whatever. And yeah, I did kind of think about that. And I thought about doing wireless instead of IR. trying to make it a more peer-to-peer protocol rather than, or excuse me, like a multi-node mesh instead of just single point-to-point. All kinds of things like that. And I have had to kind of cut myself on that. I tried to get the TV Gone working on this year's badge. I had plenty of space. It's got 32K of flash on here. I've got plenty of space, but never got it working. The timing, I was messing around with the timing on these things to use the pulse width modulators for things that I wanted to do with it, and I never got it quite working before we went live. In fact, the USB also required special use of the timer on the chip. And I was doing all of my development on my desktop at home, and it was working great. Everything was fine. I plugged it in, I was using it, and I did all the development, and it worked beautifully. And then I transferred my development environment over to my laptop like the day before I left for DEF CON in preparation, just, I'm going to need this while I'm there, and I just want to have it with me. So I transferred it all over to my laptop and tried it out, and it didn't work. And the USB stuff wasn't working. I'm like, oh crap, I have not tested this on any other machines. And so I put the call out to a bunch of my friends, Crux, who's the one who actually did the board layout and the board design on this. I asked him to try it, and he's like, yeah, it doesn't work on any of my machines. I'm like, oh no. And so I put out a bug bounty to the Darknet agents. I said, if anyone can find my bug, I will give you cool stuff. I think I offered to give a whole bunch of DefCoin and like one or two of these kits or something. A lot of people spent time working on it, but nobody could find it. So the code that's out there already still has bugs on here. It works on about half of the host controllers that you plug it into, and I haven't figured out what the commonality is between the host controllers that work and the ones that don't. So yeah, feature creep. I definitely put too much into this one. I couldn't make it all work. I feel kind of bad about that one.
Smitty, unfortunately, we're running out of time. This is absolutely fascinating, but here's the good thing. This is the rebooted Coding 101. We're moving into the new format. You're actually going to be the first crossover guest that we're going to have, because we do have you assembling the Darknet badge. We're going to be doing a special on know-how where we show people how you actually assembled that, the components that you chose, and the technique you use to attach the components to the board. And then we're bringing you back on Coding 101 to show us how you actually programmed this microcontroller. So we have that to look forward to. We still have to set up the date for you coming back on Know-How, but are you game?
Yeah, oh yeah, absolutely. Fall is crazy busy. I've got a 7-year-old daughter who's in a ballet. We've got family visiting and all kinds of things. It might have to wait until January, but yes, I'm absolutely game.
Fantastic. So we're going to have this whole hardware-software battle. It will be set off here in the Brick House. It's going to be beautiful. Mark Smitty Smith, Smitty Halibut on Twitter. I want to thank you so very much for being our special guest on Coding 101.
Absolutely. Thank you very much.
We know your Twitter address, but is there anything else that you want to tell the Twit audience about you, where they can find you, about where they can find your work? I know there's a lot of stuff you've got under NDA right now, so is there anything non-NDA that you can tell us about?
Yeah, I am a little more active on Twitter than I should be. Yeah, follow me there. I'm one of the few non-journalists you guys have on the Twit network, so I don't really have anything to pimp there. Yeah, no, follow me on Twitter, Smitty Halibut.
We'll find something. And when we have you back on Coding 101 and on Know-How, we'll make sure to push it out.
Okay.
Smitty, I'll see you next time. Thank you very much.
Cheers, mate. Thank you so much.
And you, don't forget that we've got every episode of Coding 101 available for you at our show page. If you just go to twit.tv/twitcoding101, you'll be able to find all of our episodes along with our show notes, which become very, very important when we're doing a programming episode, because we actually give you the link to download our code or to get it off of our GitHub. That means that you can use the same assets that we use in show when you're programming on your own. And don't forget that we've also got a Know-How crossover coming up, so you're going to have to go over to that show page at twit.tv/KH to find the episode on assembling the Darknet badge so that the assembly of the actual program will make sense. Now, if you are already subscribed and if you already know where our show notes page is, don't forget that you can always find out what I'm doing by going to my Twitter page at twitter.com/PadreSJ. That's at PadreSJ. If you follow me, you'll find out what we're going to be doing for each episode of Coding 101, and you'll also be able to suggest fabulous guests for future episodes of Coding 101. In fact, 3 of our future guests come specifically directly from you, people who replied me saying, so-and-so would make a great guest for Coding 101. Make it so, and we made it so. Also, don't forget that you can always find us live Thursdays at 1:30. That's Pacific time, where if you go to live.twit.tv, you'll get to see the pre-show, the post-show, and everything in between. It's a fun way to enjoy what happens in the Twit Brick House. We show you what happens as we make the sausage. And as long as you're going to watch us live, why not jump into the chat room? You'll see me responding to the chat room all the time. You guys are right there. And if you go to irc.twit.tv, you'll be able to talk to me during the show, and you'll be able to talk to the other members of the Twit TV Army. Thanks again to Smitty and to everyone here who makes the show possible, to Lisa, to Leo, to my wonderful, absolutely fantastic, super talented, intelligent TD, a man by the name of Cranky Hippo, Brian Burnett. He probably doesn't have a camera on himself right now because he's shy.
I'm just busy messing with you.
He's just busy messing with me. But Brian, can you tell the folks where they can find you on the Twit TV network?
I think this is the closest I have to a shot. Yeah, you can follow me at cranky_hippo and watch us on Know How. We have lots of fun doing that show.
Yes, we do. Until next time, I'm Father Robert Ballecer, the Digital Jesuit. This has been Coding 101. End of line.